Now we go on to study the values of different parameters of the ellipse in two standard orientations. So firstly we have a diagram. As you can see, the ellipse is either horizontal or vertical based on whether A is greater than B or less than B. And now you see the equation of both the ellipses are the same in form, but because of the comparison of A and B, they will make the difference in their actual orientation, as we have seen. In case of center, again it's the same for both, that's the origin, that is 0, 0. Now the vertices, if you observe, for the horizontal ellipse they are plus or minus A, 0, whereas in case of vertical ellipse they will be 0, plus or minus B. So that means in case of vertical ellipse, the vertices will lie on the y-axis themselves. You see how the terms are merely interchanged between the two orientations. Let's go ahead. The next parameter is foci. So in first case we have plus or minus AE, 0. In second case we have 0, plus or minus BE. So you see that A gets transformed to B. That's how you can remember that. Then directrices, we have X is equal to plus or minus A by E, and in other case we have Y is equal to plus or minus B by E. So once again here A and B are replaced. Then major axis is 2A and minor axis is 2B for horizontal ellipse, and they get interchanged for the vertical orientation. So that is a 2B and 2A respectively. Then next we have the relation between A and B, that is how the lengths of semi-major and semi-minor axis are related. So as we have seen in the derivation, the expression A square into 1 minus E square was called as B square, so that's the relation between them. But in case of vertical ellipse, since A is less than B, what happens is A square and B square will merely interchange the positions. Okay, so therefore you have A square is equal to B square into 1 minus E square. Now it should be noted that in both of the cases, whether it is vertical or horizontal, we have the term 1 minus E square only, simply because E is always less than 1 for the ellipse. So therefore, since the other side is a perfect square, we must have the right hand side as a positive quantity only, it can't be negative. Then next is the expression for eccentricity. Now here also it's clear that in case of horizontal it is root of A square minus B square whole upon A, and in case of vertical it is root of B square minus A square whole upon B. Going to the next parameter, we have endpoints of latus rectum. This also we have seen when we learned what is latus rectum. So for horizontal ellipse they are plus minus AE, plus minus B square upon A, simply because we know that there are two latera recta, that's the plural of latus rectum, and hence in all there will be 4 endpoints that we are talking about. Okay, so one for the latus rectum on right, and one pair on the latus rectum on the left. So there are 4 endpoints of the latus rectum, and the length of latus rectum is given by 2B square upon A for horizontal, and for vertical it is 2A square upon B. Here also once again A and B are merely exchanged in the formula. And lastly, the focal distances of a point on ellipse, that is for any point, if you consider the point to be x1, y1, so here x1 and y1 are the coordinates of any point on the ellipse, so its distances from both of the foci are given by these expressions. So depending on whether it is horizontal or vertical, the corresponding expressions will have to be used.